So, good morning, grade 12 students. Today we'll be learning of Chapter 4.2. And Chapter 4.2 is about trig ratios and special angles. So, as I said, the topic is trig ratios and special angles. Our goals for this unit will be, I can remember what the special angles are, and I can adapt them to work with radian measure. I can use equivalent trig equations to simplify calculations, and I can prove trig identities. So let's review some previous knowledge. In grade 11, you may recall learning about the dimensions of the special triangle, the cast rule, and the primary and secondary trig ratios. Let's quickly review these concepts. So, as learned previously, special triangles have the following dimensions. Take a minute and pause the video to memorize these dimensions. As learned previously, certain primary trig ratios are positive in certain quadrants. These quadrants are shown in the cast rule. So, in quadrant 1, all trig ratios are positive. In quadrant 2, the sine trig ratio is positive, while the cosine and tangent ratios are negative. In quadrant 3, the tangent ratios are positive, and the sine and cosine ratios are negative. And finally, in quadrant 4, the cosine ratios are positive, and the sine and tangent ratios are negative. Here's a quick reminder on the primary and secondary trig ratios. The primary trig ratios are cosine, sine, and tangent. When we find the cos of the angle, we look at the angles, what's adjacent to the angle, and we divide it by the hypotenuse of that angle. When we want to find the sine of an angle, we look at what's opposite of that angle, and we divide it by the hypotenuse of that angle. And finally, when we want to find the tan of an angle, we look at what's opposite of that angle and divide it by what's adjacent of that angle. Next, let's look at the secondary trig ratios, secant, cosecant, and cotangent. When we want to find the secant of an angle, we get the hypotenuse and divide it by the adjacent of that angle. When we want to find the cosecant of an angle, we look at the angle's hypotenuse and divide it by what's opposite to that angle. Finally, when we want to find the cotangent of an angle, we look at what's adjacent to the angle and divide it by the opposite of that angle. Notice that secant is the reciprocal of cosine, cosecant is the reciprocal of sine, and cotangent is the reciprocal of tan. This relationship will help you answer certain questions in this unit. If further review is necessary, please feel free to visit the following websites. Now let's look at some key concepts. We must apply some knowledge we've learned from 4.1. This knowledge includes converting degrees into radians. In order to do this, we simply take the degree given and times it by pi over 180. I won't go too in depth, but here are some quick questions. 90 degrees in radians would be pi over 2, 30 degrees would be pi over 6, 45 degrees would be pi over 4, and 60 degrees would be pi over 3. Moving on. Applying this knowledge to our special triangles gives us angles that are radians rather than degrees. Our special triangles must be read using radians in order to find exact values for trig ratios of special angles and their multiples. So let's look back at our special triangles for a minute. So instead of these degrees, we must now look at them in terms of radians. So 30 degrees must now be looked at as pi over 6. 60 degrees must now be looked at as pi over 3. 40 degrees must be looked at as pi, or 45 degrees rather, should be looked at as pi over 4. This one as well, pi over 4. And of course 90 degrees should be looked at as pi over 2. Just put that here too. So these are the new special triangles we should be looking at, ones that include radians rather than degrees. So we must be able to solve trig ratios with a given radian measure. So when we're trying to find sine 3 pi of 6, we notice that 3 pi over 6 is a multiple of pi over 6, and pi over 6 is an angle in one of our special triangles. So if we look back at our special triangles, this would be a multiple, well, 3 pi over 6 rather would be a multiple of pi over 6. So sine pi over 6 and sine 3 pi over 6 would be the same answer. So all we need to do is find the sine of pi over 6 and we get the sine of 3 pi over 6. So the sine of pi over 6, as we recently said, when you want to find the sine of an angle, you get the opposite and divide it by the hypotenuse. So in this case 1 over 2. Next we want to find the cos of this angle. So the cos would be the adjacent over the hypotenuse. So that would give us root 3 over 2. And finally we want to find the tangent of pi over 6, which would be the opposite over the adjacent, so 1 over root 3. So these would be our answers. And as the relationship we talked about before between secondary trig ratios and primary trig ratios, knowing this helps us answer these questions. So using our knowledge of the relationship between primary and secondary trig ratios, we can solve secondary trig ratios. I'm just going to put a star here to let you know this is important to know for this unit. So if we know that cosecant is the inverse of sine, and sine 3 pi over 6 equals 1 over 2, then that would mean cosecant 3 pi over 6 would equal to 2 over 1, which would equal to 2. If secant is the inverse of cosine, then our secant 3 pi over 6 would be equal to 2 over root 3. If cotangent is the inverse of tan, then cotangent 3 pi over 6 would be equal to root 3 over 1. Now let's look at some examples. Example 1. Convert 45 degrees into radians in order to find the angle value. So all we do is we do pi over 180 equals to x, and under the x we put the given degrees. So in this question we're given 45 degrees, so here we put 45. And if we look at this equation, we know we can simplify this one. 45 goes into 80 4 times, so let's simplify that. Pi over 4 equals x over 1. And we're trying to determine what x is, so we want to isolate x. So we multiply both sides by 1, and that would give us pi over 4. And that would be our final answer. 45 degrees. Let's put a therefore statement. Therefore, 45 degrees in radians would be pi over 4. Now let's look at example 2. In example 2, we are asked to find the primary trig ratios for the angle 3 pi over 6. If we look at the angle, we notice that 3 pi over 6 is a multiple of pi over 6, and pi over 6 is an angle in one of our special triangles. In order to find the primary trig ratios of 3 pi over 6, we simply find the sine, cosine, and tangent values of pi over 6. So, if we look at this special triangle, sine pi over 6, as we learned before, when you want to find the sine of an angle, we get the opposite of that angle, which would be 1, and divided by the hypotenuse of that angle, which would be 2. So sine bracket 3 pi over 6 would be equal to 1 over 2. Now let's find the cos of this angle. The cos would be the adjacent over the hypotenuse, so cos 3 pi over 6 equals root 3, which is the adjacent, over 2, which is the hypotenuse. Now finally, let's look for the tan, which would be the opposite of the angle, 1, over the adjacent of the angle, root 3. So tan 3 pi over 6 would equal to 1 over root 3. Let's move on to some other challenging questions. In example 3, we are asked to find the primary and the secondary trig ratios for the angle 4 pi over 3. So, if we look at the angle given, 4 pi over 3, we notice that 4 pi over 3 is a multiple of the angle pi over 3, and pi over 3 is an angle in one of our special triangles. In order to find the primary and secondary trig ratios of 4 pi over 3, we simply need to find the sine, cos, tan, cosecant, secant, and cotangent values of pi over 3. So if we look at our special triangle, first let's start off with sine. The sine of pi over 3 would be opposite over hypotenuse. So sine, that would mean that sine 4 pi over 3 would equal to root 3 over 2. The cos of 4 pi over 3 would equal to the adjacent over the hypotenuse, so that would be 1 over 2. And finally the tan of 4 pi over 3 would equal to the opposite of the angle over the adjacent of the angle, so that would be root 3 over 1. That would be our primary trig ratios for this angle. Now let's find our secondary trig ratios. So let's start off with cosecant. So cosecant 4 pi over 3 equals, well, let's remember the relationship we talked about earlier. Cosecant is the inverse of sine. So sine 4 pi over 3 equals root 3 over 2. Then cosecant 4 pi over 3 would equal the inverse of that, 2 over root 3. Now let's find secant 4 pi over 3. If secant is the inverse of cosine, then we know that our answer would be 2 over 1. We can simplify that to 2. And finally, let's find cotangent. If cotangent is the inverse of tan, then cotangent 4 pi over 3 would equal to 1 over root 3. It's pretty simple so far. Now let's move on to example 4. So now let's look at example 4. Example 4 asks us to find the exact answer of cosecant 2 pi over 4 plus secant pi over 4 in simplest radical form. If we look at the two angles, we know that cosecant 2 pi over 4 and secant pi over 4 are both multiples of the angle pi over 4. Pi over 4 is an angle in one of our special triangles, as we can see right here. In order to find the sum of cosecant 2 pi over 4 and secant pi over 4, we must find the cosecant and secant values of pi over 4 and add them together. So, cosecant 2 pi over 4 we know that cosecant is the inverse of sine, and sine 2 pi over 4 would equal to opposite over hypotenuse, so 1 over root 2. So if cosecant is the inverse of sine, then our answer would be root 2 over 1. Next, let's find secant pi over 4. We know that secant is the inverse of cos, so if cos pi over 4 is adjacent over hypotenuse, then the inverse of that would be root 2 over 1. So now we know the two values of cosecant 2 pi over 4 and secant pi over 4. Now let's write them out. Equals root 2 over 1 plus, let's just scratch that out, CSC cosecant 2 pi over 4 plus secant pi over 4 equals root 2 over 1 plus root 2 over 1. So we already have a common denominator, which is 1. So we just add these two together, which would give us 2 root 2 over 1. Then we can simplify that further, and our final answer would be 2 root 2. Now let's look at example 5. So example 5, the question tells us, a slide is built and shaped like a right angle triangle. The angle of elevation from the bottom of the slide to the top of the slide is 2 pi over 6. The length of the slide is 6 meters long. Determine the height of the slide's ladder, h, and round the final answer to a whole number. So if we look at the question, we're given two dimensions of the triangle, one angle and one side length. We know that the slide is a right angle triangle, so one of its angles must be pi over 2. So of course, this angle is obviously pi over 2. If we use our common sense, we know that the length of the slide is 6 meters, and this can only be 3 possible dimensions, this length, or this length. Well, if we know what a slide looks like, we know that the length of the slide is most likely going to be this length. So we put this down, 6 meters. And once again, using our common sense, we know that the slide's ladder would be this length, and let's label that h. Of elevation also, which would be 2 pi over 6. Now let's move on. In order to find the height of the ladder, we can use SOHCAHTOA. So we'd want to find the sine of 2 pi over 6. The sine of 2 pi over 6 would give us h over 6, because the opposite over hypotenuse, opposite h, hypotenuse 6. So let's write that down, h over 6. And we're trying to find h's value, so let's isolate h. We do this by multiplying both sides by 6. So h over 6 multiplied by 6 equals h. Now let's multiply the other side by 6 as well. This should give us, so let's bring out a calculator and do this together. 2 times pi divided by 6 gives us 1.047. We want to find the sine of this, so sine 1.047 would give us this, and we want to multiply that by 6, and we would get 0.109, or we want to round that actually, so our answer would be 0.11. And we need to round this, and I just realized I've made a mistake. We don't actually round this to a whole number. Let's just cross it out. Instead, let's say round this to 2 decimals. Let's cross this out as well. So your answer would be 0.11. And you may be wondering why a ladder is 0.11 meters long, but this question is just for understanding, not realism. So, anyways, let's just put it there for a statement. Therefore, the height of the slides ladder equals 0.11. Now let's move on to example 6. So example 6 asked us to find angles using sine to the power of -1 bracket 0.5 bracket within the range of 0 and 2 pi. So first we need to find the value of sine to the power of -1 bracket 0.5 bracket. So let's write this down. Sine to the power of -1 equals, oh, we need a calculator for this one. So the answer we get is 30 degrees. And in this unit, we use radians, so let's convert that into radians. So in radians, that would be pi over 6. And at this point, we need to look at the cast rule to help us determine which quadrants this would be positive in. So let's draw out the cast chart thing. Let me use a ruler. Fill out the things. CAST. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And we know that sine is positive in quadrants 1 and 2, so we want to find the values of this angle in those two quadrants. So first, in quadrant 1, we've already established what the value of this angle in quadrant 1 is. So let's just write this out. The angle equals sine equals, cross that out, equals pi over 6. And in quadrant 2, the angle equals well, let me label this real quick. 0, 2 pi, pi, 3 pi over 2, and pi over 2. So we know that up from here to here is the value of that is this pi, and we know that the value in quad 1 is pi over 6. So if we want to find the value of the angle in quad 2, then all we have to do is take pi and subtract it by this number, pi over 6. So that would be pi minus pi over 6. And in order to subtract these two, we need a common denominator, and that common denominator would be 6. So that would give us 6 pi over 6 minus pi over 6. And if there's no number in front of the pi, so the video stopped recording. I don't know why, but from where we left off, we simplified this and we got 5 pi over 6. And we're just beginning to start our therefore statement. So for our therefore statement, alright, the angles of sine to the power of -1 bracket 0.5 bracket within the range of 0 and 2 pi are, let me move this a little up, are pi over 6 and 5 pi over 6. So that would be all for today's lesson. If you're confused on any parts, feel free to rewind the video. And I hope you learned. Take care, yes.